Hello viewers, in today's class we are going to solve yet another important and conceptual problem from derivatives, right? And here we are going to solve a very interesting problem, and the problem goes like this. If f double prime of x is continuous at x is equal to 0 and f of double prime of 0 is equal to 4, then we have to find the value of this limit, right? That is limit x tends to 0, 2 times f of x minus 3 times f of 2x plus f of 4x divided by x square, right? So here what we are given a function f of x, right? So we are given a function f of x, and the second derivative of f of x is given to be continuous at x is equal to 0, right? And the value of the second derivative of f of x at x equal to 0 is given as equal to 4, right? Then we have to find the value of this limit, right? So this problem is going to be a very interesting problem. So let us solve this problem. So now viewers, in order to solve this problem, we'll take help of a very important method in differential calculus for calculating the limits, right? And the method is known as the L'Hopital's rule, right? So we are going to use the L'Hopital's rule to find out the value of this limit, right? So in L'Hopital's rule, what we usually do, we differentiate the numerator and denominator, right? When we have the condition of 0 over 0, right? So when we have the 0 over 0 form, then we apply the L'Hopital's rule, right? So let us see, if we take x is equal to 0 in this expression, right? In this expression, if we take x is equal to 0, let us see the form of this function, right? So see what we will have. We have 2 times of f of 0 minus 3 times of f of 2 times 0, right? Because we are taking x is equal to 0. So 2 times 0 is 0. And then we have f of 4 times 0, which is again 0. And in the denominator, we have 0 square, right? So 2 times f of 0 minus, here we have 3 times f of 0. And here we have f of 0 divided by 0 square is 0. Now see, 2 times f of 0 plus f of 0 is 3 times f of 0 minus 3 times f of 0 divided by 0. So 3 times f of 0 minus 3 times f of 0 is 0. So we have 0 over 0 form, right? So when x is equal to 0, then the form of this function is 0 over 0, right? So when limit x tends to 0, we are getting the 0 over 0 form. So here we can apply, in the first step, we'll apply the L'Hopital's rule, right? So now let us call this limit as L. So L can be written as limit x tends to 0, and we have just seen that when we take x is equal to 0, this function reduces to 0 over 0 form. So we can differentiate the numerator with respect to x and the denominator with respect to x, right? So let us see what we get. So in the denominator, the derivative of x square is simply 2x, and in the numerator we have 2 times of f prime of x, because the derivative of f of x is f prime of x, minus, see here we have 3 times f prime of 2x, right? Because the derivative of f of 2x is f prime of 2x, and then by chain rule the derivative of 2x is 2, right? Because the derivative of x is 1. And here we have f of 4x, the derivative of f of 4x is f prime of 4x, and then by chain rule the derivative of 4x is 4 because the derivative of x is 1, right? So now we can simplify it. So we have limit x tends to 0, we have 2 times f prime of x minus, this is 3 times 2, that is 6 f prime of 2x. Then we have here 4 times of f prime of 4x divided by 2x, right? So now when we apply L'Hopital's rule in the first stage, after taking the derivatives, the limit L assumes this form, right? Okay, so now let us come to the second step. Now see, if we again see, uh, if we take x is equal to 0 and we substitute it in the numerator and denominator, let us see what we get, right? Because here also in the second step we'll use the L'Hopital's rule. So let us substitute x is equal to 0 in the numerator and denominator. So what we will get, see, 2 times f prime of 0 because x is 0, then we have minus 6 f prime of 2 times of 0 is again 0, then we have 4 times f prime of 4 times 0 is 0 divided by 2 times of 0, right? So here we are again taking x is equal to 0 in the numerator and in the denominator to test whether we get the 0 by 0 form in the second step or not, right? So once we get 0 over 0 form in this expression, then we can again differentiate it in the numerator and in the denominator. So now let us simplify it. So we have 2 times f prime of 0 minus 6 times f prime of 0. So 2 minus 6 is minus 4 times f prime of 0, and this is plus 4 times f prime of 0, right? And in the denominator we have 2 times 0 is 0, so minus 4, and here we have 4 f prime of 0 f prime of 0, so we have got 0 over 0 form, right? So in the second step as well we are getting the 0 by 0 form, so hence we'll again differentiate the numerator and denominator with respect to x. So now this limit L becomes limit x tends to 0, so differentiate it. So here we have 2 times f, now we'll have double prime of x because f prime of x is differentiated, and we get f of double prime of x, right? And here we have minus 6, and if we differentiate f prime of 2x, we'll get f double prime of 2x, and by chain rule the derivative of 2x is 2 because the derivative of x is 1. Then we have 4, here we have f of double prime of 4x, and by chain rule the derivative of 4x is simply 4, and in the denominator we have 2 times 1 because the derivative of x is 1, right? So now we have limit x tends to 0, here we have 2 times f double prime of x minus this is 6 times 2, that is 12, and f double prime of 2x, and then we have 4 times 4, that is 16, and f double prime of 4x, and divided by 2, right? So now viewers, we have applied the L'Hopital's rule to this limit twice, right? And we have obtained this limit. Now limit x tends to 0, and we have this expression. So when limit x tends to 0, this limit L can now be written as taking x is equal to 0. In this expression, see what we get. We get 2 times f double prime of 0, then we have minus 12, and f double prime of 2 times 0, because now we are directly taking x is equal to 0. So here we have 0, and here we have plus 16, times f double prime of 4 times 0 is 0, and in the denominator we have 2, right? So now the limit L is equal to C. All these are like terms, so we have 16 plus 2 is 18, and 18 minus 12 is 6, right? So we have 6 times of f of double prime of 0 divided by 2, and this is 2 times 3, and we have 3 times of f of double prime of 0, right? So see, we are already given the second derivative of f at x is equal to 0 is 4, so this is 3 times 4, that is 12, right? So now the value of this limit L when x tends to 0 is equal to 12, right? So this is how we have seen that how we can apply the L'Hopital's rule to solve these type of problems, right? So here the final limit L is equal to 12.